This is the review for the 3D portion of the exam. So for the geometry. Now for this one right here, we're gonna look at the standard GMD1. So for this one right here, we have a lot of things that go along with this. And so the number one thing, so if you go through your notes, we could actually find this piece in our notes. The Cavalari's principle. So in our notes, under my standard for that, we have Cavalari's principle. Let's see, grab it real quick. So I want to pull it out of the notes for this. So it's actually built into the page of the notes. I let someone borrow my notebook and it just turned into a hot mess. Raw. Alright, so for in page 41, it looks like this. We have Cavalari's principle right there in the middle. So this is actually going to be the answers to the test, but we got some people not paying attention to it, so it's going to be fine. Okay, they don't need answers. All right, so Cavalari's principle. If two solids have the same height, same cross-sectional area, so a cross-section means if I slice it to the middle, if it's going to be the same shape, okay, at every level, then the two solids have the same volume. So what I'm trying to show is, now, list 3 things that the two solids shown below have in common. Okay, I just listed it from that principle right there. So what do you think the first one should be? I just read it. Come on, come on.
They both share
Same height. So, first one, same height. This is in your notes. It should be right there. It's not a trick question. Same height. What else?
Same volume.
Same volume. What else? Same cross section. So same cross section. So there we go. Okay. Cross section area. So it's just straight out of the notes. So it's almost like I already knew what the question was going to be on the test and gave you the answer beforehand. All you had to do was actually look at it. Scary. All right, so Evan has popcorn container in the shape of a square prism, could hold 360 cubic inches. Right there. So, right here, he also has a square pyramid-shaped container with the same height. So the height is going to be the same. And base side lengths are the same. So that means that these here are the same. And they both have the same height. Okay. How many pyramid-shaped containers can fill from the pyramid-shaped, how many pyramid-shaped containers can be filled from the prism-shaped container? Explain your answer. Now, first, what is the formula for the prism? What's the volume of prism?
Length times width times height.
Yep, length times width times height, right? Now, for the pyramid, what is the volume of the pyramid?
1/3 pi times length. Pi times all length times.
So length times width times height, right? Length, width, height. So it's the area of the base times the height. So area of the base is length times width. So LW, LW. So it's going to be length times width times height here. And this is length times width times height. But what's the difference in between these two?
Third.
This is 1/3, right? So if this is 1/3, how many of these will fit into that?
Three.
How do we know it's 3?
So it's at third.
Yeah. So, because there'll be 3 of these that will make into this. It's going to be 3. The pyramid and the cone is always 1/3. So it will always be 3 of these pyramids will go into those. To make one hole, I need 3 of those. And we just get this from the formula right there. So it's 1/3 of that formula, right? So if I have 2 of those, that's going to be how much? 2/3. And if I have 3 of them, it is 3/3, which is a whole, right? That's what we're trying for. Now, what's my reasoning behind it? Right there, look at the formulas. See the formulas, the difference in the formulas right there. How many cubic inches will the pyramid container hold? Now, if this one holds 360, what would I do to figure out how much this one would hold? Think about it. If the volume is 360 here, divided by 3, right? I would take this volume right here and divide that by 3. So if I take this divided by 3, so this volume right here, 120 inches cubed. Because I took this volume right here and divided by 3, because that's what I have to do with my pyramids and cones. So 120 inches cubed. I'm hoping you guys all get this right, because I don't want to have to do this one over again. All right, let's take a look at the backside, or backside of that page at least. Now, this goes along with the cross sections, okay? Along with my cross sections right here. Okay, so I'm going to start off with a cone. Now, let's take a look. Here's my cone. I have a little handy dandy piece right here. So if it's parallel to the base, so I'm going to start with parallel to base, it should be exactly the same as the base, right? It should be exactly the same as the base. So if it's parallel to the base, now what shape is the base? So there we go. So the cross section parallel is a circle. Now, cross section perpendicular. So perpendicular means, let's see if I can get this just right. Here we go. Okay, so it's not going parallel, it's going straight up and down. Okay, so if I took this and I made it flat, that's why I'm trying to do the optical illusion right now with the camera, so you guys could only see the 2-dimensional here. What shape do you think that makes? That's going to make a triangle, right? So if I look directly on it, what shape does the outside make? It makes a triangle. So that is my perpendicular, so that's a triangle. Sphere. Now, sphere. Here's my sphere. Okay? Now, parallel to the base. This is the base right here. Anywhere I slice it, what shape is it going to make? There it goes. Makes a circle. I'm not looking for the 3-dimensional. Hemisphere would be right, but I'm just looking for the shape, the 2D shape. So think of this as just 2D shapes. Okay? These are all 2D. So this one's a circle. Okay, and cross section that cuts the other direction. Circle. Rectangular prism. There's my rectangular prism. Now, if I cut it, so this is the base right here, right? If I cut it parallel to the base, right here, what shape will that be? It'll be another rectangle, right? So I'll be another rectangle. Is that the wrong shape? Yeah, it should be there. There's a rectangular one. So there it is. So that's a rectangle. Now, so if this one's the base, okay, the blue one's right here's the base, okay? So I'm going to cut it perpendicular to the base. So instead of cutting it same way, this would be cutting same way. I'm now going to be cutting this way. So if I cut this way, what shape is it going to make? It's going to make this rectangle right here, right? So if I cut it this way, it makes the same shape right there, right? So cut it this way, this is perpendicular to the base, I get another rectangle, right? Okay. Now let's take a look at my cylinder. Now, if I cut it parallel to the base, what do I see?
Circle.
Okay, parallel is going to give me a circle. Now, I'm going to slice it this way, perpendicular to the base. Okay, I'm going to slice it this way, so watch. Okay, so I'm going to come over here, I'm going to slice it, and then I'm going to come up with this shape right here. It's going to be a rectangle because kind of the three-dimensional thing. So if you look at it, what is the outside? So if this is the base right here, and I'm cutting it this way, so I'm making a flat surface right here. So if I'm looking at it flat, just think about it, what shape is the outside right here? That's a rectangle there, right? So that's going to be a rectangle. So perpendicular on my cylinder is going to be my rectangle. Does that make sense? Hopefully. Okay, draw a 2D shape that would produce the solid if rotated 360 degrees. So let's take a look. So I'm going to start with a line here. Now, and it's going to be the same line that I have here. Remember when I was doing the rotating on the board? It was going around the axes. So what do you think the 2D shape would be? So what, I'm going to start right here. So I'm going to sketch this way. So I have my triangle on top, right? And then right here, this piece right here is going to become a rectangle. So this is the 2D shape. So this 2D shape, if I rotate it around this axis right here, if I rotate it around that axis, that means that this is going to give me the 3D shape out of that, right? Does that make sense? Is there any questions over that? This is on the test, and when is the test? Tomorrow. So I'm hoping you guys are following along, not over there snoozing. Okay. Okay, so now this one right here. Draw the solid revolution formed by the shape rotated. So now, this is a 2D. So now whenever I do that, then I'm going to draw the reflection on the other side. Okay? Yes, it is Senior Cacahuate. There we go. So, now, I drew that there, right? I drew the reflection. Do you guys see that? Also, are you paying attention?
Yeah.
All right, did you draw the reflection?
Yeah.
Now, we have to show curvature. On all the drawings and stuff that show three-dimensional, they show curvature, don't they? So now, for any of this, I'm going to draw like the dotted line in between to show that it has a curvature. So if you want to draw dotted lines, kind of like that. So to show curvature in there. That's the number one thing. So you have to draw the dotted lines to show curvature, how it's curving around. Make sense? Okay, so now this one right here is just like my warm-up. Okay, you drill out a block of wood. Okay, so now to find the volume of what is left over, wouldn't this be the cube, right? Minus the cone. The cube minus the cone. All right, so my volume would be volume of the cube. How would I find the volume of the cube?
1/3 times pi times r squared, right?
Cube, just cube. So it's going to be 5 times, what's this value over here?
5.
This one is going to be 5. This is a 5 by 5 here. That's important because it's supposed to be of this dimension. So right here, so I have a 5 here, I have a 5 here. So it's 5 times 5 times, what's the height of the cube? 7. Very good. There's the cube minus the cone. The cone is 1/3 pi. What's the radius of the cube?
1.5.
1.5. because we have the diameter, which is all the way across here, right? Diameter is 3, so the radius is half of the diameter, which is going to give me 1.5 squared times why 5?
That's the height of the cone.
The cone only goes down 5 centimeters, right? That's all I needed. So now, can I put it all in the calculator as is? Yes, let's do that, please. All right, let's see what we got. Can you guys see that? Okay, so it's going to be 5 times 7 minus, it's going to be parentheses around all this. So just to make sure I put it in the right spot. So 1/3 pi and 1.5 closed squared times 5. Okay, so when you're doing this problem, especially on the test, if you don't write out your formula, you're not going to get partial points on that. So you have to write out your formula, show your work of what you're doing, okay? So, round to the whole number. What's my answer going to be in the whole number? What is it? 163, because 2 is not going to make that one go up, right? So it's going to be 163 what? What are my units? Centimeters. Thank you. Questions? No? Okay, let's move on. Now, the last one, we just need to use our handy dandy notebook for this, our handy dandy, okay, with all of our formulas, because this is a big chunk of my points. Now, cylinder. The formula for a cylinder is going to be volume is pi r squared h. So it's going to be pi, gives me my radius, 4 squared times 8. Round your answer to the 10th. It says right there, round your answer to the 10th. So I get 402.1. cm cubed. The cone, volume is 1/3 pi r squared h. So my volume is pi, my 4 squared times 10. There's my 1/3 in there. That's a third. 1/3. Okay, so I have my 1/3 pi 4 squared times 10. So this one's going to be 167 point.
5.
Nope, not 5.
6.
Why is it going to be 6?
Because we do rounds up.
The second 5, right? The second 5 is going to make that 5 go up 1. Because they're rounding to that number. So it's going to be 167.6 cm cubed. A sphere, volume is 4/3 pi r cubed. And remember to do the third power, you do a caret 3. Okay, it's right here next to the x squared. It's to the left of it. And I get 268.1. 268.1. And my units are centimeters cubed. Next one, rectangular prism. Volume is length times width times height. So it's going to be volume is 4 times 2 times 5. So my volume is going to be 80. Nope. 40. 40 centimeters cubed. And the pyramid. So this is a pyramid, so we're going to assume it's going to be a rectangular base. So volume is 1/3 length times width times height. So it's 1/3 4 times 2 times 5. And control divide, we get 13.3. Does that make sense? That's going to be a whole lot like you're going to see on the test. You're going to have to find a whole bunch of formulas right there. You already have the formulas. I'm going to let you use your handy dandy on this. So if you have any questions, please double check the video. All right. That's why I say like and subscribe, right?